Now I would like to introduce our second speaker, Dr. Felix. Dr. Felix is a lecturer in spatial data science at the University of Manchester with research focused on modeling urbanization in developing cities, simulating socio-spatial growth patterns, and applying machine learning to predict living conditions. He leads as an ESRC funded project on urban expansion in African cities and has worked on satellite-based poverty predictions and consumption models in other places. Dr. Felix, karibu.
Thank you very much, Heba. If we were in a courtroom and I was tasked to prosecute the case for modeling urban expansion, I would just say, my lords, Patrick's presentation is Exhibit A. He's actually set the foundation right for why we have to talk about modeling urban expansion. Yes, I'll say, and this is off the back of a publication in Environment and Planning B, where we experimented or we piloted an urban expansion model in Accra. And I say we, it's myself and Professor Sean Fox from the University of Bristol, who is sitting at the back, and then Professor Elizabeth Silva at the University of Cambridge. So why do we have to bother ourselves about modeling urban expansion? Well, as Patrick's presentation showed, we have to plan for urban expansion. Africa is expecting about 1 billion additional urban dwellers by 2050. Actual figure is about 900 million. What does this mean? Well, it means that we have to know where these people are likely to live, where the expected urban dwellers are likely to live, which has implications for infrastructure planning, for resource allocation, which areas should get more, and also for urban and environmental policy formulation. So the objective of the project is actually fourfold. The first one is to model urban expansion, develop a model for modeling urban expansion, and to validate the model is very important. We have lots of models, but we have to know the model actually works. So we have to validate the model and also use the validated model to then generate predictions of urban expansion, which would then be the foundation for planning for that expansion. And we should also be able to use the model, which has been validated, and that means we have to build capacity by way of training local planners as to not how just to use the model, but to also tweak the model if they want to. What is different about South Africa's urbanization? As Patrick's presentation showed, it is largely informal. And I will highlight two features. I mean, there are more to the informality of urbanization in Africa, but I'm going to highlight two major features. One is household self-build in a context of ambiguous, nebulous property rights, and also majority of development occurring without planning permit. So I was here last year, and in other cities as well, including Kumasi, Nairobi, Lagos, and Pretoria. And I engaged with experts of urban development, stakeholders, and we asked them, in their opinion, what is the percentage of development in their city that is without permit, and also percentage of development that are provided by households themselves. So on the x-axis, you have percentage of development by households. On y-axis, you have percentage of development without planning permit. And look at the cities. You have Lagos, Nairobi, Kumasi, all in this quadrant. So the broken lines represent the midpoint of the various axes, right? So it means you have majority of the 4 cities that I went to basically being largely informal, as in development occurring without permit in larger quantities, and also largely supplied by households in what we describe as self-build. So how have we modeled urban expansion in Africa? Modeling urban expansion is not new. What approaches have been used? So here we reviewed approaches that have been applied to modeling urban expansion in the global south, Africa being a region here. So we have Africa here, and the most popular modeling approaches, singular modeling approaches, cellular automata and agent-based modeling. You also have recently the combination of approaches known as integrated approaches. I'm going to talk a little bit more about this. Why do we need new models since we have already, urban expansion models? Well, the challenge is that urban expansion models that are existing currently are ill-suited or poorly suited to Africa's urban expansion trajectory and patterns. So the image you see here, it's word cloud analysis from the input parameters of existing models that have been applied in the global south, including Africa. Now, what do we see here? We can see the dominant parameters being, say, road, slope, land cover, exclusion, urban land. All these are geophysical factors or variables. We're not seeing the parameters that are related to housing market, to land market, which are very important if we want to be able to model the largely informal urban expansion that we experience in Africa. And the most popular model that has been applied worldwide and also in Africa is SLUTE. SLUTE was developed in the US, and it's been applied extensively in the world and also in Africa. Now, the challenge with SLUTE is that, like other cellular automata models, I don't want to be too technical, so cellular automata is the modeling approach underpinning SLUTE. And for all other cellular automata models, they do not directly model the social processes. So the housing market dynamics, the land market dynamics that contribute or that generate the physical built-up patterns that we observe are not modeled by SLUTE and other CA models. And so, for instance, SLUTE has no parameter for population. So we need better models if we want to model Africa's urban expansion more accurately. Then comes in our model, which we have titled the Informal City Model, TICT model for short. And the model combines two major modeling approaches, cellular automata and agent-based models, to model urban growth. And here urban growth will mean predicting the locations of new urban development and also the legal status of those development, whether they are likely to be formal or informal, and also the economic status of those development. Will the development be occupied by low income, middle income, or high income households? So these are the three core objectives of TICT model. So let me introduce you to the framework of TICT model. So the model is set up to mimic housing markets or development markets in most African cities. So what the model does is it creates agents that we see in most markets in Africa. You have households, and then you also have estate developers. Then you have your land parcels. Now, land parcels have characteristics or have attributes, including, say, land price, whether the land is already developed or is vacant, the zoning status of the land, slope of the land. In the model, households are able to self-build, unlike many other existing models. Real estate developers too are able to build in the model, and you have government that regulate the activities of both. So government performs development control function in the model. So you can express this quite simply, that if development will occur on location J, if agent I will develop on location J, then it's a function of these factors: how physically suitable the place is, how affordable the place is, the utility that the agent would, or the household, or the developer would derive from locating or building at the place, and also whether they are allowed to develop or not based on the extent of development control. So I've mentioned development control several times. I'm going to come back to that a little bit shortly. So in the model, how do the agents behave? So the agents being households, developers, and government. Households account for the majority of development that occur in the model, and they are bounded by some theories, one being satisficing. So we think that we don't have perfect information. So households will try to locate in places where utility is high, not the highest utility because they don't have all the information in the market. So we use decision tree. Households go through this process to settle at a place. So first they will ask, is the land vacant? If the land is not vacant, the household will look for another land that is vacant. If the land is vacant, is the land physically developable? So if you look at the geophysical characteristics of the land, slope for instance, can you physically develop the land? If the answer is no, we'll look for another parcel. If the answer is yes, the next question is affordability. Can I afford the land? If the answer is no, we'll look for another parcel. Answer is yes, Then the next question is, does the land offer generally high utility? If the answer is no, look for another parcel. If the answer is yes, the agent would locate on that parcel. So the model uses this decision tree really to determine how development occurs. So we model the utility of parcels dynamically, so we don't assume that the satisfaction that households would derive from land parcels is constant throughout the years. We account for neighborhood effect. So if you have a parcel where, say, households, low-income households, don't have generally high utility for it, say parcel kill, okay? So let's say parcel kill at time one, current time, so there is low utility, low utility for low-income households, but then parcel 1, 5, and 7, which are neighbors of parcel kill, you have low-income households moving to those parcels, right? What is happening here is that parcel kill would update its status, so all of a sudden it will become attractive for low-income households. So because of what has happened in the neighborhood of Paso Kill, now Paso Kill would be occupied by low-income households. So we account for the neighborhood effect in the model. Development control, I've kept on mentioning it, which is very important. To be able to account for the role of government in development, we need a development control parameter. So the model has this parameter, which ranges from 0 to 100, so you can have any value in between. 0 means basically it's free for all. Government development control is weak, at its weakest. Development can occur without any regulation. 100 means government is able to perfectly regulate development. For cities, it's actually somewhere in between. For most African cities, it's closer to 0 than it is to 100. So what the model does is it classifies lands that are not zoned as residential, lands that are not planned, and also lands that are not titled as being more likely for informal development. So if development occurs on any of these lands, then we classify that development as informal. And as to whether development can occur on any of these 3 lands, it depends on the development control parameter. So if the parameter is set to 10, then it means about 90% of these lands will become available in the market for agents to really select if they find it attractive. So using this framework, we apply the model. We need to test it in the real world. We apply the model to Accra City region, which is quite large, has a population of about 7 million people. It's 100 square kilometer area, so quite large. And the area accounts for Ghana's, a quarter of Ghana's GDP. It holds also about a quarter of Ghana's population, Accra. So what we did was to go back in time. We went as far back as 2000, used the model to predict urban expansion of Accra in 2010, okay? Then we compared the prediction from the model to what actually occurred, okay? So what you see here, the red parcels are parcels where we correctly predicted. So we said that by 2010, development would occur, or the model said that, and indeed by 2010, development occurred there. The black parcels are the areas where we predicted, but development did not occur there by 2010. Now, the area that I've just, this area in the bubble, we predicted development to occur there in 2010, but as you can see, development did not occur there in 2010. However, we realized development started occurring there from 2012, and by 2015, the entire area was built up. As you can see, you have a lot of reds as well where the model performed quite well. Now, whether we can say the model is performing well or not, we need to be able to benchmark it or reference or compare it to something. So we compare the model to SLUTE, which is the state-of-the-art model in the field. So we also went as far back as 2000, applied SLUTE in the same way, and we compared the extent to which TICT is able to predict urban expansion compared to SLUTE. So this is the performance of SLUTE right, TICT left. As you can see, when it comes to inner city development or infilling, both models do quite well. But when it comes to the peri-urban or suburban expansion, SLUTE does not perform quite well compared to TICT. TICT is picking these chunks of peri-urban expansion, which SLUTE is actually missing, as you can see from the screen. We can put numbers to it. And when we do so, this is what we see. The extent to which both models explain the variations or the variance in the built-up patterns that we observed in 2010, TICT is able to explain up to about 60, 65, 62%, 65% actually, whereas SLUT only explains highest 20% of the variations that occurred. So TICT outperforms SLUT quite significantly. And using that, based on the performance of the model in being able to predict the locations of urban expansion, we then used it to predict Accra's urban expansion by 2030. And we also did same for income status and legal status. I haven't talked about that side because we've not really had data to validate it. Hopefully, we'll be able to validate that side of the model in this project, which is still ongoing. And in terms of how the model has been applied in the real world, so recently, just 2024, last year, the government of Ghana approved the structure plan, which has recently been prepared. And in the structure plan for Accra, TICT was used as the model to predict business as usual scenario urban expansion, that if Accra does not change its trajectory, what is likely to occur. And that is what you see in the red, that those are the areas the model is predicting urban expansion. So using that as basis, the planners who prepared or who developed the master plan or the structure plan for Accra then came up with development scenarios, okay? So one scenario was the business as usual scenario, which is based on the prediction from TICT. And then they were able to use that prediction to quantify the impact of that expected urban expansion on forest land, on cropland, which has implications for food security, on water cover, water resources, and also on shrubland. Then they said, you know what, we don't like this, so we need to develop alternative scenarios. And these are the scenarios that they developed. One scenario was this: cities or centers at the edge, that we want something new, but we recognize the power of the existing market. If the model is predicting that development will occur in these areas, why don't we then guide those developments? So plan for that expansion, as I'll use Patrick's terminology. So this is how the model has informed real-world planning. And we're scaling up this application to different cities in Africa, and that is why I was here in Nairobi and was also in Pretoria and Lagos, Kumasi as well. And these are the cities that we're trying to apply the model to. Thank you very much. My time is up.